Okay, this is the review for the exponents test. It is tomorrow, so hopefully you have the review. So the first part here says write an equivalent expression for each of the following. These are exponents. You need to remember the laws of exponents for these. So the first one, I know it sounds silly that I say this, but this line right here, what does that mean? That should tell you which law or which rule you need to use for dividing rule. Yes, so divide means to subtract this number from that one. So you're going to take 6 minus 2, and that's going to give you the new exponent because they have the same base of a. So that's a to the 4. This one right here, there's a power right on the outside of the parentheses. So that power needs to get multiplied times any other exponents or powers on the inside. However, there's only one of them here. So that's going to be a to the 6 times 2. So that's a to the 12. Okay. This one here, try not to be confused. This is a multiplication. Usually they put like a little dot right there in between. However, multiply, the rule for the exponents is to add. So that's 8 plus a negative 3. As long as they have the same base, that would be a to the 5. The next one here, a to the negative 5. It doesn't look like there's anything to do, but remember the rule is no negative exponents. So this a to the negative 5, we would have to kind of make a fractional problem out of it. And now it's a to the positive 5. And since there's nothing else here, we just put an invisible 1. Put your 1 on top. The number 5 is just like number 3. What are you going to do with this 2 and this 9? We are going to add 9, 10, 11. If you are unsure about these, you can Google law of exponents or look up a YouTube video on laws of exponents. And there's different laws for dividing, multiplying, power to a power. Okay. Kimberly incorrectly simplified an expression. So here's her problem, and she got this answer right here. And it's telling you she incorrectly did it. Which of the following is the true statement that best describes her mistake? So if you're looking at a problem like this, you should notice that this rule is the multiplication rule. So we need to use the rule for multiplying exponents to help us figure out what she did wrong. Hopefully it should be very easy because multiplying exponents rule, what do I actually need to do with my exponents? I should be adding them, yes. However, what did she do with the coefficients? She also added the coefficients. That is not correct. So this negative 5 and 4, that should have gave her a negative 20 in the front. So it says she incorrectly combined the exponents. I don't think that that's actually false because 3 plus 7, that did give her a 10. That's good. Yes. So this right here, she incorrectly combined. That's false because she actually combined it correctly. The G's she did correct. The H's she did correct. She incorrectly, no, that's false. She did that correct. She added the exponents when she should have multiplied. No, she did that correct. The answer is right here. This is what she did wrong. Like we said, she should have multiplied the coefficients, but she added them instead. Number 7. I hope you remember we talked about this one maybe once or twice. And it gives you, it says that rectangle has an area of 12x to the 7, y to the 8, and a length of 6x to the 3rd y. Determine the width. So try not to get confused because they're not asking you to find the area. They actually want you to find the width, determine the width. Does anybody remember? Yes. So you're going to take what the area is, and you're going to divide it by the 6x to the third, divided by the length. However, be careful, just because we say divide, you need to remember the rules for dividing exponents. Just because we say divide doesn't mean go through dividing everything. But the coefficients, yes, you need to divide 12 divided by 6. And that should help you eliminate, there's something wrong here. 12 divided by 6. That should help you eliminate A and C. Once you take 12 divided by 6, go on to this 7 and this 3 because they both have a power of x. So if there's a little bit on top, a little bit on the bottom, the dividing exponent rule means to actually subtract. 7 take away 3. 7 take away 3 is going to give you a x to the power of 4. Look at that. That's x to the power of 10. That means that can't be right either. And if you want to just double check yourself, this will be 8 take away invisible 1, which, yes, is a 7. So there's your answer right there. Yes, remember, those little ones are always invisible. So, I mean, I don't know, maybe they got lazy and they just stopped writing the ones. Yeah, but they never put the ones. You just got to remember. So looking at this one, we haven't really talked about expanding these before, but remember, a power of 2 means that there's 2 x's getting multiplied on top, and a power of 5 means there's how many? 5 at the bottom. Because here they're asking which of the following is not equivalent. So you got to make sure you understand, like, this could be written in several different forms. So there's 2 x's on top, 5 x's on bottom. That's that answer. So this is actually equal. We're looking for the one that's not equal. So if we were to go through and start canceling out these two, that would make the invisible 1. And these two cancel to make invisible 1. Notice how many x's are left. There's 3 x's left, but where are they left? They're at the bottom. So technically that is the same thing as this, because this right here tells you there's 3 x's left on bottom, and then there's an invisible 1 on top, and here the invisible 1 is on top. So this one is also equal. Now there's a big difference between these two. This right here, if you do the math right here, multiply straight across. What's 1 times 1 times 1? 1. And what's x times x times x? X to the third. And that is also equal to that one. So the one that is not equal is B. Because this is saying that there's 3 x's left, but they're not at the bottom of the fraction. I'll pause it. So number 9 goes back to our multiplication rule. Earlier somebody said, Miss, how do I know that it's not a division rule? And I said, okay, remember, if it's a division rule, you're going to see something like a fraction bar or a fraction sign, or you will actually see the dividing sign. However, this is a multiplication rule again. Multiplication rule. That means you can multiply the coefficients. So 20 times 5, what does that give you? So it definitely can't be that or that, because 20 times 5 has to have a 100 somewhere in it. Okay, so we know so far we got 100. Now what am I going to do with my x to the power of 4? Uh-oh. Is there any other x's? No, so I'm going to keep x to the power of 4. Now I'm looking at my y's. That's y to the negative 2 and y to the 7. I'm going to add those powers. So what's negative 2 plus 7? 5. So that's y to the power of 5. And for my z's, I'm going to take, here we go, invisible power of 1 again, and negative 3. I have to add a 1 with a negative 3. And that's going to give me z to the negative 2. So even if you didn't know what to do with that negative 2 on that z, if you forgot the negative power rule, look at this z. This z does not have a negative 2. Also, look at this y. It needs to have a power of 5. This y has a power of 9. So we know it can't be a either. A lot of these you can do by just making sure you eliminate the wrong answers. So just to make sure you understand the negative power rule, the reason why they ended up writing it down here is because you cannot leave anything with a negative power. You move it to the bottom, or the denominator. Okay. Any questions? Moving on to the next part. All right, which expression is equivalent to this one? This is a dividing rule because it has the fraction bar. So we can actually divide. What can we actually divide? 12 divided by 4. Does that leave you with an 8? 12 divided by 4 should not leave you with the coefficient of 8. We are dividing. 12 divided by 4 should not leave you with the big 8. So we took care of 12 and 4. What am I going to do with my p's? Subtract. So that's 6 take away 3 for the p's. 6 take away 3, that will leave 3p to the 3. So I want to make sure my answer has p to the 3. How did p to the 8? That's not going to help me. I don't need that. Notice, we just got that problem done without even moving on to the q or the r's. However, I do want to explain something else you could have noticed. This is the only q, base of q. There's no other bases of q. Q to the 2 is on the bottom and it needs to stay at the bottom. Don't even touch it. There's nothing else that needs to get subtracted with it. So q to the 2 definitely should be at the bottom. So it just confirms that C is our answer. All right, number 11. The graph shown represents a population of bacteria over time. Which of the following is not a true statement? So looking at it, you have to know how to find the initial value. And the initial value is always found on the y-intercept. So does it look like it was about 50?
Yes.
So it looks like it's counting like 2, 4, 6, 8, but in between it would be 200, 300, 400, 500, 600. So they're counting by 100s. Is that dot, I know it's kind of tiny,
Yes,
but
it would be like 50.
it's like halfway to the 100. Yeah. So this one is actually true because it did start off at about 50 bacteria. Now it says the population increased by 100 each hour. Notice this shape, this is an exponential shape. If it says increase by 100, it means it's adding 100 each hour. If it's adding 100, that would mean it's going to be linear. This is not a linear graph. Linear means it has to make a straight line. So that one's definitely false. Now doubled is true because it was at 50, and then by the 1 it's at 100. Then at the 2 it's at 200. Then at the 3 it is at 400. So it is getting multiplied times 2 each hour. So it looks like we already found our one that's not true, which is B. Some people really needed to make a table so they can see all of the values. That's fine. At the 0, we were at 50, and at the 1, it was at 100. At the 2, it was at 200. At the 3, it was at 400. So you can definitely see how it was doubling each time. 50 times 2 is 100. 100 times 2 is 200. 200 times 2 is 400. So that's how I knew C was true, because it is definitely doubling every hour. Number 12, a lot of people were kind of tripping about this one. It says, which of the following is a geometric sequence with a common ratio of a fourth? Common ratio of a fourth is the same thing as a rate of 1 over 4. Or what's the same thing as 1 over 4.25? So we're looking to see which of these values should it be increasing or decreasing, you think? It should definitely be decreasing, because look at your rate. It's a fourth. It's less than 1. It's between 0 and 1. So decreasing means the number should be getting smaller. So you might be able to eliminate anything that looks like the numbers are getting bigger. So if you look at C, these numbers are increasing. That's not what we need. Look at D. It went from 16 to 4 to negative 4, but then it hops back up to a 16. Definitely can't be D either. So be careful. It's either going to be A or B. And this, you're definitely going to need your calculator for this one. I'm going to start off with 96. Start off with 96. And then I'm going to use my rate, which means to multiply it times a fourth. Or even if you want to use your alpha y equals. So multiply it times 1 over 4. And then see what it gives you. It gives you 24. And then if you really want to double check and multiply that times 1 over 4 again, it will give you 6. You see that? So the answer is A. Because each time we're multiplying by 1 over 4. Let me know if you have questions. If I'm going too quick, I'll pause it for you. So 13 and 14, once again, it goes the same thing with our exponential functions. One question you should ask yourself, is it increasing or decrease? Make sure you remember how to find or where to locate the A value and the B value. Do you remember what the A is? The A is the what? There's a couple of different names for it. The y-intercept can also be the initial value or the starting point or the starting number. The B is going to be your rate. The rate always has the power of x on it. So looking at the equation, Myra's savings account balance can be determined by this equation. What does the 3,000 represent? So you have to know what this means and this means. Is the 3,000 going to be the rate? No, the 3,000 is going to be the starting point or the initial value. So be careful because it's definitely not the rate. So we can cancel out A because it says rate. And then it's also, B is kind of tricky. It says the amount of interest earned in the first year. The keyword first might trick people. But we know it's definitely not C. The number of years since Myra opened the account. That doesn't make sense at all. All right, so between B and D, you have to be very careful because D says the starting balance of the savings account. However, B says the amount of interest earned in the first year. So be careful. Initial value means that's what we started with. So the answer should be D for that one. Some people earlier thought it was B just because they seen the keyword first. Make sure you know exactly what they're talking about. Number 14. The population of a town of 3,000 increases by 7% every year over the next 3 years. If the domain is 0, 1, 2, 3 for the situation, if the domain of 0, 1, 2, 3 for this situation represents the years that the town's population was recorded, they're asking for a range. So basically, if you make a table, they told you the domain is 0, 1, 2, 3. You got to figure out what the range is. You can figure out what the range is by using the equation, if you know how to set up the equation. So what would the A value be for your equation? Yep, what did the population start with? Good, 3,000. However, finding the rate, be careful because it's a percentage rate. And we know it has to increase. So I know a lot of people were used to taking the 100% thing, but be careful. If it's increasing, do you want to subtract it from 100 or do you want to add it? Yes. Increasing means to add it to the 100, turn it into a decimal, so it's going to be 1.07. Excuse me. 1.07. That's going to be the equation you could use to fill in the missing blanks in your table. So in your y equals 3,000 parentheses 1.07 parentheses to the power of x. If that x is not a power, you are not going to get the correct answer. Press second graph and fill in your table. 3,000, 3210, 3434.7, and you can definitely see your answer on that one. And we know it couldn't have been B because that's actually a decay. So the answer looks like it is D.